Hello everyone, this is Maurizio, editor-in-chief of Power Electronics News and Embedded.com, and I am here in Milan at NI Days, and I have the pleasure to be here with Kevin Schultz, CTO of NI Emerson. Hi Kevin, thanks a lot for being here. How are you?
Hello Maurizio, glad to be here.
Thank you, thanks a lot. So we are at NI Days in Milan, so we talked different topics. So let's focus about AI on test and measurement. So AI, as you know, is revolutionizing different fields. So test and measurement, as well as other topics like signal processing, FPGAs, that I would like to know more about this topic. Let's start with AI. So during an opening in the last NI Connect in Austin last year, you said also AI would have an impact even bigger. Indeed, so it is. So can you elaborate about the impact of AI on test and measurement? What are your expectations?
Sure, yeah. Obviously, I do think it's going to have a huge impact for multiple reasons. One is test and measurement really is about data acquisition, acquiring a large amount of data, and that's the foundation of AI. So by having this much data, AI can come in and do analysis, processing, abstraction of it, and the result is it can fundamentally change the workflow in test and measurement. It can change the engineer's job to be done where it becomes a lot more task-oriented than workflow. And that's why I believe, coupled with the billions of dollars being invested in AI in the industry, it is going to be the biggest technology change I've seen in my career.
Thank you. So another topic is FPGA. So FPGAs have long been a key enabler for high-performance test and measurement. Considering AI, the advent of AI, how they are evolving in this AI-driven era, also considering the combination with the CPU, GPU, AI accelerators, and so on.
Yeah, I mean, we really brought FPGAs to test and measurement roughly 20 years ago. And the concept that you could, certain things to process in a PC or a processor and certain things you should do in the FPGA, which is a lot closer to point of measurement, deterministic. Well, GPUs actually now brings another level of processing to it. And the FPGAs are continuing to advance. They're great on power. They're great on deterministic, fixed functionality stuff. But they are attached now to a GPU, and they can do peer-to-peer with the GPUs, and you can start having GPUs at all different levels also. So the combination of an FPGA, a GPU, and a processor really opens up the opportunities for our customers. It gives them endless possibilities. What you're going to see with FPGAs is obviously still a core part for it with fixed, I'll say, lower power, functionality, deterministic, but there'll be a lot more direct connection in having, GPU blocks inside the FPGAs, just like there'll be GPUs in parallel with the PC or the processor. And that aspect is, it makes it more complex, but then our software will help abstract that to the customer so they can use the processing engine that makes most sense to them.
So, an system, when would become intelligent, so a system intelligent can predict, can learn, can adapt, can perceive. So how this would shift the testing from a traditional approach that we know to automated predictive process?
Yeah, I mean, that's a great question. I mean, there's no doubt how much this technology is changing. That answer is anybody's guess, right? We do know that there's a lot of aspects in testing that sometimes it's hard to set up and, I'll say, define what is passed and what is failed. It might be easier to say, I know this one is working and I know this is a good one. If you look at vibration or machine condition monitoring, for example, it might be straightforward to say, train on what's running right now and then use AI to just look for an anomaly from that. That's one possibility, but I think in a lot of other cases, it's going to be a lot more on adapting and adjusting to the engineer workflow. Still let the engineer focus on what they do best, but then use the AI to complement that as it goes forward.
So let's talk about the signal processing. So we talk about AI, FPGA, signal processing. Signal processing will be advanced at the point of measurement. So how, considering AI, how is AI enhancing real-time signal processing at the instrument level?
Well, I mean, I think it depends what you can do at the instrument level, right? And case by case, whether it be filtering, anomaly detection, noise
Sure.
reduction, there's certain aspects that the customer is going to use in, either discrete logic or an FPGA for, probably in filtering. But like I mentioned in anomaly detection, they'll use the AI at that point. So they can start looking at these things or looking at these measurements and deciding case by case what makes the most sense. So there's not one straightforward answer. I think noise reduction is one that could be done both ways. For example, we're using AI in some cases, just like DSP blocks have been used before. In other cases, we're doing it with discrete logic. And so AI just gives it another tool. And that lines up with our platform well. I've always said we've had the most intelligent platform for many years because of the amount of data we can move and acquire. Now this gives another tool of processing to our customers to solve their complex problems.
So AI adoption comes with challenges in terms of data security, in terms of integration, but also in terms of market. So where do you see trouble? What are the biggest obstacles that companies should face in this regard?
Well, obviously with any new technology, there's always some, I'll say, fear, uncertainty, and doubt. And, AI is also similar to working with a colleague. I've heard multiple people say, well, it gives me a different answer each time. I can tell you when I work with individuals, they give me a different answer each time also, right? So there's no doubt there's a learning curve on it. There's been cases where if you're using a large language model in the cloud, obviously a lot of companies, especially depending on the industry they're in, do not want to put any proprietary information up in the cloud where it could possibly be trained. So in that case, they'd have to run on a local model. All these things are being learned. I will say, I think there's a couple things that are crucial. One is obviously understand the technology, work with trusted providers. For example, we work with Microsoft in many cases in their environment, work with trusted providers, and then 3, be open and flexible, trying to learn as you go. And with that case, and then finally, I guess, have governance, have strict governance. It is a powerful tool, but it can also be misused. And some industries, there's more of a concern than others, but it's something that every company should be worrying about governance.
Thank you. So my last one, Kevin. So are we ready for AI? What should engineers do today to be prepared for the future?
Well, there's 2 things I would say to every engineer to embrace AI. One is be open to a paradigm shift. Be open to a change in how they develop, how their workflow is, because it is a big technology. It's being billions. But I think the more important one right now is get your data in order. If you look at it, the foundation of what make AI work is data, contextualized data, not just the waveform acquired, but more information about how it was acquired, when it was acquired, where it was acquired. With that information, then AI can run their data analysis, run on top of it, and really take advantage of it. I've been talking to multiple companies already. They're excited about AI, and then when we talk about their data is not ready for AI. And I can say that's step 1, is get your data in order.
Thank you, Kevin. Thanks a lot for your time.